Here's a quick video that will help you relate some of our SI units, our International System of Measurement units, if you're not super familiar with them. And as Americans, we don't use these commonly, so they can be hard to kind of think about how they relate, how big they are, how small they are. And I'm going to try to help you visualize some of that. So we will start with our unit of length, the meter. Okay, I've got a meter stick here laying out on the desk. The meter, of course, has 100 centimeters in it, which we see marked off here. So that's not too hard to think about, right? Cents in a dollar, there's 100 cents in a dollar, 100 years in a century. So we've got our 100 centimeters in the meter. And then our smaller marks, we will notice, you've got 10 of those per centimeter. So there's 1,000 millimeters in a meter. That's our smallest mark. Think years in a millennium, right? 1,000 years in a millennium, 1,000 millimeters in a meter. There's also some nice tie-ins to volume, okay? So this orange cube here is a 10 centimeter by 10 centimeter by 10 centimeter cube. So it's 10 times 10 times 10, 1,000 cubic centimeters. 10 times 10 times 10. An individual cubic centimeter looks like this. And you can see if you put it on the meter stick, it's a centimeter by a centimeter by a centimeter. So it's a cubic centimeter, and you would have 1,000 of those in this particular cube. Now, a couple of links to another volume unit that we use, liters and millimeters. So this 10 by 10 by 10 centimeter cube is equivalent to a liter, okay? Which means I've got 1,000 of these in a liter, so a cubic centimeter is also equal to a milliliter. So when we talk about milliliters, we often talk about liquid volume. So we use graduated cylinders to measure that. And a milliliter, so on this particular graduated cylinder, each line is a milliliter. You can think of it as kind of a flat disc. Each one of those milliliters is equivalent in volume to this cubic centimeter. Okay, so again, coming back to our liter cube, it has a volume of 1,000 cubic centimeters, or 1,000 milliliters, or again, it's also called a liter. There's also a nice tie-in between volume and mass. So this particular cubic centimeter, again, if I were to make this up of water at its most dense temperature, which happens to be 4 degrees Celsius, don't worry too much about that, it would have a mass of 1 gram. So we use water as a standard to go between volume and mass, and water is the standard. So if this cubic centimeter has a mass of 1 gram, the liter, is 1,000 times more volume, is also going to have 1,000 times more mass. So the liter is going to have a mass of 1,000 grams. Well, in the SI system, 1,000, the prefix is kilos. So if I were to fill this with water, I'd have 1,000 cubic centimeters, which would have a mass of 1,000 grams or a kilogram. So if you imagine filling this up with water and holding it in your hands, that mass that you're feeling would be equivalent to a kilogram, and that happens to be about 2.2 pounds. I want to show a kind of an interesting demonstration to prove this, and I want to go between my big graduated cylinder over here. So this big graduated cylinder is actually a 1,000 milliliter graduated cylinder. If I get down at eye level, I try to fill it up right to the 1,000 milliliter mark. And so that 1,000 milliliters should also have a mass of 1,000 grams. And for me, when I look at these two things next to one another, they do not seem like they have equal volumes. But I'm going to go ahead and prove that to you, and also show you that it has a mass of 1,000 grams. Now this water is not at 4 degrees Celsius, so it may not work out to the gram, but we should be pretty close. If we were to measure the mass of the water in that graduated cylinder, we should have 1,000 grams. So let me get that set up. I'm going to bring over an electronic balance, turn it on. And hopefully you can see it's reading 0 grams right now. I'm gonna take this liter cube and put it on the scale. Of course, I need to 0 it now. I'll hit the tare button. And I'm gonna carefully pour the 1,000 milliliters from the graduated cylinder into the liter cube. And let's see what happens. Just to show you there are no tricks here. I always feel like the graduated cylinder has more volume for some reason. But we're getting close here. And it is a pretty perfect fit. I haven't gotten every last drop out of the graduated cylinder, but hopefully you can see that the mass is reading 991 grams. It's actually kind of a warm day today, so the water is actually expanded a little bit. It's a little less dense today. So had I done this on a cooler day, I bet I would have been even closer to 1,000 grams. But I'm only a difference of 9 grams out of 1,000. That's a 0.9% error. That's pretty good. So hopefully that video helps you link and understand the relationship between the metric or SI units of length, volume, and mass.